In this video, we're going to have a look at how we can find those basic trig ratios in triangles. In the previous video, we saw that you name the sides of a right-angled triangle according to its position in terms of a specific angle. We called the angle theta. Then we learnt about the three ratios that you can form from this perspective of angle theta, called the sin, cos, and tan ratios. Next, we're going to have a look at how to determine these ratios for specific triangles. Example 1. Consider triangle KLM with LM 9 cm and KM 15 cm. If you have a look at the sketch, you will also see that angle M is given as 61 degrees in this right-angled triangle. Question A. Determine the length of KL. Because this is a right-angled triangle, we can use the Theorem of Pythagoras to determine the length of KL. We can say that KL squared is equal to the hypotenuse squared minus the other side squared. And we need to add the reason that we used the Theorem of Pythagoras. We are doing the subtraction because we already have the hypotenuse, which is the longest of the three sides, and we need to determine one of the shorter sides. 15 squared minus 9 squared will give you the value 144. And to calculate the length of KL, we then take the square root of 144, so KL is 12 centimeters. B. Determine each of the following ratios. We already know that these ratios are formed by two of the sides of the triangle. For the first two ratios, the perspective, the angle that we are looking from, is angle K, which means we can go and name the sides from K's perspective. The hypotenuse will always be the hypotenuse. Doesn't matter what your perspective is. But from angle K, the side right across from it, the opposite side, will be side LM. And its adjacent side, the one touching it, will be side KL. Firstly, we are asked for the sin ratio from K's perspective, and that is the opposite side over the hypotenuse, which will be 9 over 15. The cos ratio is the adjacent side, also on the hypotenuse, so that will be 12 over 15. For question 3 and 4, we are now asked for the ratios from angle M's perspective, which means we will have to name the sides all over again. I've already mentioned that the hypotenuse stays the hypotenuse, but looking from angle M, the adjacent side is now the 9 centimeters, and right across from it, 12 centimeters will now be my opposite side. Cos is still the adjacent over hypotenuse ratio, and if we look from M, that will be 9 over 15. The tan ratio is formed by the opposite side, which is 12 in this case, over the adjacent of 9. It is good if you can already realize that the sin ratio of an angle in a specific triangle will always be equal to the cos ratio of the other angle in that same triangle. Example 2. Use the sketch and give all possible ratios for the following. If you have a look at the sketch, you will see that there are three different right-angled triangles, and each of those can supply you with a possible ratio. The opposite and adjacent sides, of course, will once again be determined from which angle we are working. The hypotenuses, however, stay constant, so you can start off indicating those hypotenuses. In the blue triangle, the hypotenuse is side AB. In the green triangle, the hypotenuse is side CB. And in the big orange triangle, the hypotenuse is side AC. For the first question, we need to determine the sine ratio from angle A's perspective. So, focusing on angle A, you need to realize that it is part of the blue as well as the orange triangle. Focusing on the blue triangle from angle A, we can then say that the opposite side is side DB and the adjacent side is side AD. Sin is the ratio opposite over hypotenuse, and for the blue triangle, that will be side DB over side AB. Next, if we have a look at the orange triangle from A's perspective, side BC is our opposite side, and side AB will be the adjacent side. For the sin ratio, we are looking for the opposite side over the hypotenuse. So for the orange triangle, that will be CB over AC. In question B, we now need to determine the tan ratio from angle C's perspective. And again, angle C forms part of two triangles, the green as well as the orange triangle. Looking at the green triangle from C's perspective, we can say that side DB will be the opposite side and DC will be the adjacent side. The tan ratio is the opposite over adjacent side, so in this case that will be side DB over side DC. Next, if we have a look at the orange triangle from C's perspective, side AB will be the opposite side and side CB the adjacent side. Again, we need to get the tan ratio, which is the opposite over adjacent sides. So for the orange triangle, that will be side AB over side CB.